You are welcome back. Let's continue with this our energy level in an atom. I've given you the general formula of a Planck constant, and the Planck constant is only talking about the energy of a photon. I get the energy of a photon or quantum. You know that. And the formula is what we refer to as E equal to hf. And that E equal to hf from the speed of light, which is c equal to f dot lambda. We can now derive it as what? E equal to hf also equal to what? hc over lambda. Try to master this formula. But let me interpret the formula where E equal to what? Photon energy. The capital letter E in the formula represents photon energy. H in the formula equal to the Planck constant. H equal to the Planck constant. You can put the value in the bracket, but anyway, in any exam that you want to write, they will give you that. But the value of that is now 6.626 multiplied by 10 raised to the power minus 34 joule seconds. I get it now. Then F is the frequency. I get it now. Then C in that case, that is the velocity of light. I know the velocity of light to be 3.0 multiplied by 10 raised to the power 8 meter per seconds. Then what remains? Then this lambda is the same thing as the wavelength. Is that taking? The same thing as the wavelength. But now I want to explain the energy transmission. I want to explain the energy. No, I want to explain the energy transition. But before I will do that, let me still pause this video for a while, then we continue from there. Are you getting that? Okay, class, let's continue with our teaching. Now I want to take you to this energy level per se. It's very simple, but some students find it so difficult. But I'll try as much as possible to explain it to you in a way that you'll be able to get it. Even when you see it in question, you'll be able to attend to it in a proper way. Now look at the board. This is what I'm trying to do the other time, because I don't want to use time to waste time for that. Now I call it energy transition. And this energy transition, I get in that is what we just discussed in the last class before talking about this. That is talking about this energy level in atom. Now you all know what they call shell. Now look at the diagram here. We all believe that our atoms look like this. You know, when you are talking about Rutherford, we're telling us that one of the limitations Rutherford had is that it can only explain it based on what? Based on one shell, hydrogen atom. And you have only one. That is, we can talk about it when you have an element that has only one electron in its atomos shell. They said it cannot explain it with multiple electrons. But this time around, we have more than one shell. I get it now. But if you look at this, that is what we call energy level. I get it now. That is what the boys in there, and with the help of Max Planck, to now refer to this as energy level. Don't mind me. You can see some figure here. Have 0 electron volts, 4 electron volts, 6 electron volts, 7 electron volts. And if you look at this also, I have it also. What they are saying in essence that look at this look at this energy shell. That means this line also represents energy shell. But in a normal way, if you find this kind of question, what you need to do, I will still tell you, is just to draw a vertical line across this. I get it now. Because there's nothing will happen to this. I get it now. If you like place your electron here, place it here, it has no meaning. At the, what do you call it? When something is moving like at the x-axis, it has no effect at the x-axis. That is horizontally, it has no effect. The energy we are talking about has effect only at the vertical line, but student normally mix it up. It has no effect whether you place it here, whether you place it there, it's still the same shell. I get it now. It's now your own problem that you want to put it there, you want to put it there. No, but it has effect on what? On the vertical line. You can see that the vertical line here, if I check it vertically, maybe I draw it like this, I will still show that later. I have this. I get it now. That means the vertical, the what we call it, the energy level here. This is the ground state energy level, and the I now represent with what is 0 electron volt. I call this place 4 electron volt. I call this place 6 electron volt, and I call this place 7 electron volt. We are still talking about the same thing. Don't mind me. So that is what we are saying. That is what we are saying. But I want to explain this. Now, look up. Normally, whether you are talking about the negative or the positive, I get it now. When it's moving up, you are talking about it as increasing positive energy value. That is, you are increasing here. That is, when it's going like this, that is increasing positive values. Increasing positive value. Moving from this to this, that is the positive value. But what they are saying in essence is this: you can still start this from down, but if I'm starting this from down now, it will now be what? Minus. That means I will now have minus 7 electron volts, minus 6 electron volt, minus 4 electron volt, then 0 electron. After 0, you have positive. Do you understand that? That is what they are saying. Now, but now you can see that each, and you have this is the first energy level. That is what you normally call K, L, M, N. You can still remember that. Now, this N represents the quantum number. That is the energy level of that arrangement. That is what he's saying there. Quantum number. I get it now. But what I want to really explain is this. What they are saying is in this case is this. Now, let us assume I have an electron here. Now, then the electron is here with positive charge. They are telling us, normally this electron will be moving around, but this electron, when this electron is in its stationary state, I explained that when I was talking about the model of an atom under Niels Bohr. When it is in its stationary state, I get it now, that is when it can emit energy or absorb energy. Do you understand that now? I don't know where you have to get that. Now, what they are saying, if this electron here from this lower state, I get it now, let us use this upper state. They call this is the first excitation state, second excitation state, third excitation state. The same thing here that you want first excitation state, second excitation state, third excitation state. Let us assume this one is now excited, is in its excited state. What will have happened to it? That means a photon have traveled down to this electron. That means this electron will gain what? We gain a photon. And what I call that photon? Quantum or energy. When it gains that photon, that is when it will now have the ability to jump from this state, energy level, to this energy level. Do you understand that now? Let's now assume this have reached is what? Excited state. Then the electron have jumped down to this state. Do you understand that now? You know, I normally use the word photon when you are restless. I get it now. That is what I mean by that, photon. Now, when this one jump, you know, when it join, it gain what? What happens to it? It absorb energy. I get it now. I get it now. It absorbed energy to jump to the next energy level. So when you do that, it will release a photon. The photon that it receive, that is what we call that ray of light. That's what we call absorption spectrum. Do you get that? But now at this excitation state, a state will come that this electron will jump back to this state. It can move from here to here, it can move, it depends. But if it decided to jump back to this place, what will happen? It will now emit a photon, a ray of light. Do you understand that? That is what we are saying. It's just like this. It can move from here to here. But for this to move from here to the next energy state, what is this? 4 electron volts. That means this need to gain 4 electron volts before it can move from here to here. If you want to come back from here to here, you need to emit, throw away electron volt of 4 electron volts before it can move back to this stage. That is what this is talking about. Do you get that now? But because we very soon we move on to the calculation under this. Now, but let's see this. You can write now. You can write in model of the hydrogen atom, the energy of an electron in the energy level is given by, very, very important formula, will be given by this. You can have it, let me put it somewhere here. You can have E equal to what? No, let me use minus. E equal to minus E naught over N. I get it now. That is, if I want to calculate the energy at this level, I just use any energy, energy electron volt I have interest. But if I want to calculate the real energy state here, that means E will now be E naught over N. I get it now. But at the same time, you can still rewrite it. When you have a change, because there is a change, then there is a change in energy level from here to here. So this formula has to change. I get it now. Do you understand what I mean? It has to, no, N squared, it should be N squared. N squared. Take note of that. N squared. E equal to minus E naught over N squared. Do you understand that now? But if, okay, can I rub up this one? If you have this, let me even put it here. You have this, you can say E equal to what? Minus E naught over N squared. But if you have a change in energy level, that means your formula will change. That means I will now add or I have it in this. If this change in energy, we are talking about change in energy, it will now be equal to minus, open bracket, 1 over N upper squared. Yes, minus 1 over N lower squared, then multiply by what? Multiply by E naught. Do you understand that? Multiply by E naught. That will be the change in energy level. Take note of that formula. But where, let's explain that where E is the what? E is the energy of electron in energy level. E naught will represent a constant. We call it constant. E naught is a constant, which is also equal to 13.6 electron volts. Do you understand that? That is E naught. E naught in this case is a what? Is a constant, which is now equal to what? 13.6 electron volts. 13.6 electron volts. Is that taken? Then what do you have again? We have your Nu. In that case, what will be your Nu? Upper electron quantum. I get right. Upper electron, that is quantum number. Upper electron, that is, if you move from here to here, n equal to 2 will now be upper. That is upper quantum number. While NL will represent the lower quantum number. Will represent the lower quantum number. But take note of this before I round up this class. To convert 1 electron volt to joule, I want to convert 1 electron volt to joule. 1 electron volt to joule. Okay. 1 electron volt to joule. Let me rub up this side. 1 electron volt to joule. 1 electron volt to joule. That means I will have, I want to convert 1 electron volt to joule. This is still the same thing as 1 multiplied by what? Electron volts. Because electron volt is just a unit that the Planck constant used to calculate its energy. But you can take what? You can take electron volt to joule. That means you're going to multiply by 1.6 multiply by 10 raised to the power minus 19. That means if I have this now, if I have 1 electron volt should now be equal to 1 multiplied by 1.6 times 10 raised to the power 19 joule. So it's already, so at the end of the day, you know that 1 electron volt is the same thing as what? 1.6 times 10 raised to the power minus 19 joule. Can you see that now? That is when you can convert what? From 1 electron volt to joule. Do you understand that now? So it's just like, let me say for example from I don't have those things again. Okay, let me use like this E naught. Let's convert E naught to joule. So that means by EG we have 13.6 electron volt. But I want to convert this to, let's convert to what? To joule. Let me convert it to joule. So if I want to convert this to joule, that means I will just have 13.6 electron volt. That means I'm only going to multiply it by what? By 1.6 multiplied by 10 raised to the power minus 13. That means this should now be equal to what? 13.6 multiplied by what? 1.6 times 10 raised to the power what? Minus 19 is already in joule. So which is still the same thing. 13. Let's see that. 13.6 multiplied by 1.6. I mean 13.6 times 1.6, that would be 21.76 multiplied by what? 10 raised to the power minus 19 joule. Or we have it as 2.2 or 2.18 times 10. This one with 10, that will be 10 raised to the power minus 18 joule. That is what they are talking under this. So I see you next class. Then I will talk about full calculation of under this. I've explained the basic concepts you need under this topic. What I will employ you to do, just go through them, master some key formula that we talk about. Like this formula, I'll tell you how to use this formula and when to use that formula. And I'll also talk about the Planck constant. But sorry class, let me quickly talk about that Planck constant, the change in energy level. Another formula that we need under this energy transition. We've talked about this, that from Planck constant, that E equal to what? Call it E. Okay, I've even talked about that formula before, but I need it under this concept because we're going to use it. Let me bring it back to this place. So if I have E equal to HF, I know that is also equal to what? HC over what? Over lambda. But when you have a change in energy level, when you have a change in energy level, that is, I brought it up from that diagram of an energy diagram. I draw for you 0 electron volt, 4 electron volt, 6 electron volt. Let us mean it jump from the lower energy level to the what? Higher energy level. There is a change. That means jump from E2, jump from E1. You can jump from E1 to E2, and you can jump also from E2 to E3, and you can jump directly from E1. I get now E1 to E4. Do you understand that now? Do you get that? So let us assume there's a change now. That means I can still have this E upper energy minus lower energy, which is also equal to what? HF also equal to what? HC over lambda. These are the principles that by next class under the question we are going to use. I'm very, very tired. I see you. Good night.